Hello there, I wanted to show you how easy it is to use the TI-84 graphing calculator to construct confidence intervals for population means. In section 7.1, I showed you how to use the TI-84 to construct confidence intervals for population proportions. That was from section 7.1. Now we're in section 7.2, dealing with confidence intervals for population means. As the lecture and book explain, you sometimes do use the Z distribution, but more than not, you use a T student distribution based on not knowing sigma, that's population standard deviation, and often we have small sample sizes, which give rise to the use of the T distribution. Sometimes you have the data, and you either plug it into technology or you hand compute the sample statistics of the sample mean and sample statistics that you would then plug into the graphing calculator to construct the confidence interval, or you just put the data in. So I'm going to go to my list operator. If you push stat and edit option 1, this is a clear list on the graphing calculator. And earlier, a few years back, I loaded the calculator with this list of the data from the first example on the handout given in class, where there were 15 statistics students asked to estimate the number of hours they spend per week watching television. If I push enter here, I can go second stat into a bunch of lists that I have preloaded, and it's this list right here, hours TV, that if I push enter, it will enter all those values. You'd have to manually enter them in if you didn't have this list. But those are the same 15 values that are on the handout. As far as constructing the confidence interval, it's probably a good idea after I show you what the confidence interval that the calculator will construct on this versus what was given on the worksheet. The worksheet that I did, I used rounded values, and the calculator is going to construct a more accurate confidence interval based on not rounding the sample mean and sample standard deviation. So if I push stat and go over to tests, we saw that option A in section 7.1, we used the 1 prop Z interval, not 1 prop Z test. We're going to use the T interval because this is a sample where we don't know the standard deviation for the population of student average weekly television viewing hours. So we're going to use the T distribution. I push enter, and sometimes you have the statistics already. And if that's the case, you just put the mean and the sample standard deviation here, the sample size, and the confidence level. But since we have data, I'm going to go over to data and push enter, and it immediately says, where have you put that data? I have put it in list 1, so I'll leave that as list 1. If it was somewhere else, notice that if you push the second 1 button above it, there's an L1. And each of the data values have a frequency of 1. The desired confidence level for this confidence interval was 95%. So I changed that to 0.95. I simply push the calculate button, and it gives me a confidence interval. And it does go from 3.08 to 9.19, which is definitely a little bit off from the value given on the worksheet. And that's because I rounded my mean, my sample mean, to 6.1, when you can see it looks like 6.13 repeating. And in my calculation, I used a standard deviation of 5.5, and this is more than 5.5. So that's the reason why if you were to use those more accurate values for the mean and the standard deviation on the worksheet, you would have seen that this confidence interval would have occurred. Number 2 was a problem dealing with psychology graduate students and conducting some study on hypnotherapy. And they found that after participating in a hypnosis session, that there was an increased number of hours of sleep. And so they requested that 12 random students mention how many hours they slept after the hypnosis session. So this is not data that was collected, but in the problem, we're told what the average amount of sleeps was for the sample of 12 people, and we've found the sample standard deviation. So this time I would push stat, go over to tests, again go into the T interval, which I can do by just simply pushing the 8 button since it's the 8th item in this list. And we're back in the T interval menu, but this time because we already have the sample statistics provided to us, we click on stats and push enter to activate that, and we have to put in the mean, which on the worksheet you saw was 8.98 hours of sleep. Oh, I wish. and the standard deviation was 1.29. And this came from a sample of 12 people. And the desired confidence level for this confidence interval was 99%. So we would come down here and change this to 0.99. And since I'm putting in the same values with the same accuracy that I used on the hand-drawn calculations on the worksheet, when I calculate this, you will see that to the closest hundredth that this is a confidence interval from anywhere from 7.82 hours of sleep up to 10.14 hours of sleep. So that was a constructed confidence interval using the t-student distribution. On the back side of the sheet, you'll see option number 3 is the very rare situation where we're constructing a confidence interval for the population mean when somehow we don't know this. We know the population standard deviation. If we're constructing a confidence interval for the population mean, it's because we don't know the population mean. And if we don't know the population mean, it doesn't really make a lot of sense that we would somehow know the population standard deviation. These problems are actually quite rare in the real world. But nonetheless, you will have to do a few of them. So if you push stat and go over to tests, you'll notice that this is option 7 for the z interval. So if you push 7 on your sheet, the default is stats, and we are given the statistical information. The sample stats information is that the average birth weight here of girls was 31.1 hectograms. So we're going to change the mean to be 31.1. And somehow we know that the population standard deviation, which is sigma, is 2.9 pounds, or actually hectograms. 2.9 hectograms, and the mean is 31.1. We're asked to construct a confidence interval, and because we know sigma, we're going to use the z normal distribution. And that's why we're using the interval tool here. The size of the sample was 22, which will change here, and then we change the confidence level to 95 as is desired in this question. So we're constructing a 95% confidence interval. And we push the calculate button, and voila, you'll notice to the closest tenth, this would round to 29.9, and this would round to 32.3, which completely match up with the values on the worksheet. I'm going to show you how easy it is to construct population mean confidence intervals in the TI graphing